To answer this question, before that we have to recap the definition of gravitational field. Gravitational field is actually a region whereby a mass experiences a gravitational force. Okay, so now let's go through the options. A. Gravitational fields cause forces on objects because they are charged. Okay, this is not right. Okay, there is a force because they have mass. Okay, B. Only planets and stars have gravitational field. Okay, so this is wrong also. Gravitational field occurs around any masses. So only it is more significant because on planets and on stars they have very huge mass. That's why the gravitational field is more significant. Whereas for something that is small like a pencil or a pen, it actually has got gravitational field around it, just that it's very insignificant and we don't realize it. Okay, option C. The gravitational field of the Earth acts inwards towards the center of the Earth. Okay, this is correct, and that is why our weight always acts downwards to the center of the Earth, because the gravitational field and the weight, they should be acting in the same direction. And option D, the gravitational field strength on Moon is less than Earth because there is no atmosphere on the Earth. Sorry, there is no atmosphere on the Moon. Okay, this is not correct also. Just now I mentioned about the gravitational field. It depends on the mass of the object. So Earth is 6 times bigger than the Moon. That's why the gravitational field strength of Earth is about 6 times larger than Moon. It's not because of the atmosphere. Okay, we have a window that is pivoted along this axis, and there are 2 forces acting on it, which are the weight and the force of 30 Newton at this position. Okay, so to simplify this diagram, right, we can actually represent it with a beam like this. Okay, so the entire length of this beam is 0.3 plus 0.7, that will be 1 meter. And the pivot is located at 0.3 meter from the left edge of the beam. Okay, so there's a pivot here, 0.3 meter, and the weight is located 0.2 meter from the pivot. So it's a downward with a weight of 100 Newton. This is 0.2, and there is a force right at the end at a distance of 0.5 meter away from the weight, and this is a upward force of 30 Newton. Okay, so in this case, what is the resultant moment? We can see that there is a clockwise moment produced by the weight. So it will be force times distance. The clockwise moment is equal to force times distance, 100 times 0.2, that will be 20 Newton meter. And there is an anti-clockwise moment of 30 times the distance, which is 0.2 plus 0.5 meter, that will be 0.7 meter. So it's 21 Newton meter. So the resultant moment will be taking the larger moment minus of the smaller moment. So 21 minus 20, we have a resultant moment of 1 Newton meter. The answer will be A. Okay, we have a non-uniform object shown by this diagram here. Okay, it's being pivoted on a knife edge at point C. And I have a weight that is suspended on the left side of the object. So this is going to cause a downward force. It's going to cause an anti-clockwise moment. Okay, so the center of gravity of the object, it must produce a clockwise moment to cancel out this anti-clockwise moment so that it can be balanced. Okay, so now if let's say the center of gravity of the object which is acting downwards, if it's at A, it's going to cause a anti-clockwise moment as well. So it's going to cause it to topple even faster. So A cannot be the answer. If it's at B, also it will cause a anti-clockwise moment, so it cannot be the answer. If it's being placed at C, the weight of the object is going to cut through the pivot and then there will be no resultant moment, so it cannot be the answer as well. So the weight of the object must be at D. Okay, when it's at D, it will cause it to turn clockwise, so this clockwise moment can counter this anti-clockwise moment such that it can balance the object. So the answer should be D. Okay, we are asked how much energy does the pump needs to supply to lift 1 kg of water up into the water tank. Okay, so the water comes from a reservoir, so the reservoir is already at this height. So in order to pump the water up to the tank, right, we just need to give the water 10 meter worth of gravitational potential energy such that it can go up to the tank. So in this case, to calculate the amount of energy required, it will be gravitational potential energy of 10 meter. That will be the mass, gravitational field strength, and the height multiplied together. So the mass is 1 kg, gravitational field strength is 10, and the height is 10 also. So we just need to supply 100 joules of energy to raise 1 kg of water up into the water tank here. So the answer should be B. Okay, we will first look at how much energy is being used by the battery at night. Okay, so energy is equal to power times time. Okay, 1.2 watt means that it uses 1.2 joules of energy every second. So in this case, it will be 1.2 multiplied by 18,000 seconds, and that we will get 21600 joules. Okay, so this is the amount of energy that is being used at night. So in the day, we have to store up this amount of energy, and every second the battery will store 1.6 joules of energy. So how many seconds does it take? We will just take 21600 divided by 1.6, and that will give us the answer as 13500 seconds. Okay, so the answer should be B.